This week, you guys did really, really well on your quizzes. Some of you are going to be frustrated with the mistake that you made. Okay? The number one mistake was power to a power. 2a squared b to the third raised to the fifth power. 2 gets the fifth power, a squared gets the fifth power, b cubed gets the fifth power. You guys were a good job doing 2 to the fifth, which is 32. Yep, 32. When you raise a power to a power, what do you do to your exponents? You multiply. Most of you added them, which then you lost points on. After we take notes today, I will get you back I have a whole bunch of papers I haven't given back to you guys. And when you go into Alex, you can click on your report and see your actual quiz now. I released it to you, so you can be able to go through that as well. And here's the thing, you want to go through that because Friday you have a test, and these exponent rules are on there. We only have 2 new things that we're learning this week, and then you're taking a test on it. Okay, so the majority of it is those exponent laws. Cool? All right, so this week, we're going to take notes in your book today, and you have an online assignment. You don't have to bring your book the rest of the week, because then Tuesday, you're going to have a worksheet, which I'll give you notes for. Wednesday, I'll give you a note page, and you're online, and then you have your review and your test. Okay? Friday is also the end of the quarter, so make sure that not only in my class, but in all your classes, you're checking for any missing work, as Friday is going to be your deadline to get that in. All righty? Okay, notice no calculators today because we're talking scientific notation. Scientific notation is a way of writing really, really large numbers or really, really small numbers in a condensed format. A format that are easier to look at, to talk about, to compare, or even just to work with. So a really large number would be 425 million. Yep, 425 million can actually be rewritten in a condensed version. All scientific notation is going to have an x for times and a base 10. So it's always a number times 10 to blank power. Now, there's a couple of rules on the left-hand side under the work zone. Write this down. The number one rule, the number out front can only have 1 digit in front of the decimal. Proper scientific notation, you can only have 1 digit in front of the decimal. And the number I'm talking about is like this 4.25. The only number in front of the decimal is a 4. So when we place this decimal today, we need to place it so that there's only 1 digit in front. When you want to write a number if they give it to us in scientific notation, actually, we'll write that when we get down to it, okay? All right, so directions for these first ones. Write each number in standard form. Notice they give it to us in scientific notation. How do I know it's in scientific notation? Because it's times 10 to a power, okay? When it's given to us in scientific notation and we want standard form, here's what we need to write down on the left-hand side. Oh, it's even in this post-it. You don't even have to write it down. Maybe just underline it. Positive power moves to the right. Positive power moves to the right. Positive exponent, you move your decimal to the right. Negative power, you move to the left. Negative to the left. That's kind of nice. You don't have to even rewrite it. Positive, just like on a number line, positive numbers are to the right. Negative numbers are to the left. So let's go in the middle here to got it, A, B, and C. They give us our numbers in scientific notation. 7.42 times 10 to the fifth. What do you notice about the exponent? It's positive. So that tells me I'm moving which direction? Right. I am moving to the right. Okay? So we have the number 7.42. Scientific notation moves the decimal point. Moves the decimal 5 steps to the right. So we swoop. 1, 2, 3, 4, 5. My decimal point is now at the end. What do you think I need to put in those open swoops? Zeros. So 7.42 times 10 to the 5th is actually 742,000. Where is my decimal point? At the end on the right. Technically, do I have to put it there? No. Miss Hoff is not worried about commas either. On Alex today, it's going to say, although your answer is correct, you really should have commas. Miss Hoff doesn't worry about commas right now. It's more important that you know where the decimal needs to be. Okay? Got it, B. What's my exponent tell me? Negative. What does that mean? I'm moving to the left. So I have 6.1. And I'm moving to the left how many? 2. 1, 2. So now my decimal point is out front. Point. What do I need in that open swoop? 0, 6, 1. 0.061. Now somebody right away is going to say, what if I put a 0 in front of that decimal? Is that okay? Yep. Sure. Do you have to? Ms. Hoff isn't crazy about it. Notice how I make a big decimal point though. One thing I am going to make sure is make sure it's very obvious where your decimal point is. Got it, C. What's my exponent tell me? Positive means I'm moving to the right. So I have 3.714. How many to the right am I going? 2. Oh, I screwed this up. There's no zeros on it. Does it matter? Nope. No. My final answer. 371.4. Very good. I moved my decimal. You only have one decimal point in each of these numbers. You're moving the decimal. Okay, you're moving the decimal. So they gave us scientific notation. We wrote it in standard form. The second half of what we're doing today is they're going to give us standard form, the expanded number. We want to write it in scientific notation. Ms. Hoff hates the examples. Okay, so go to the top of page 53. All right. On the right-hand side, write down these steps. Number 1, ask if the number is greater or less than 1. You need to ask yourself, is this number greater or less than 1? Greater than 1 or less than 1? If it's greater than 1, that means you have a positive exponent. And if it's less than 1, guess what you have? A negative exponent. Make that determination right away. So let's do this with Got It D. We look at the number on Got It D. Is that number greater than 1 or less than 1? Greater than 1. So that tells us that our exponent is positive. It is greater than 1, so our exponent is positive. Now, currently, where is my decimal point? At the end. A lot of people say, well, there isn't one. Well, technically, they didn't put it there, but it is way here at the end. We need to place our decimal point to follow scientific notation rules of 1 digit in front of the decimal. Where should I place my decimal point so that only 1 digit is in front of it? Say it again. Here, 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 here. Is there only 1 digit in front of that decimal? No. You need to place it. What's a digit? A number. I can only have 1 number in front of that. Gable, where do you want it? Here? Is there only one digit in front of it? Yes. Now, with scientific notation, the beauty of it is that we don't have to write all the extra zeros. We just have to worry about our numbers. If there's a whole bunch of zeros, we can skip them. So all we are going to write down is this first piece, 1.414 times 10 to the, now count between them. How many swoops or decimal movements are between those two decimal places? 7, and you told me it is a positive 7. That is that number in scientific notation. So let's repeat the process. Look at E. First question you ask yourself. What's the first question you ask yourself? Is it greater than 1 or less than 1? Less than 1. So what do you know? Negative exponent. Currently, where's my decimal point? Between the two zeros. Where do I need to place it so that I only have one number in front of the decimal? In front of the 8 like this?
No, behind the 8.
Behind the 8. Like this? Okay, you can only have one number in front of the decimal though. Is she correct?
No.
She's correct. This decimal right here, if I put it here, the only digit, remember zeros don't count, the only number in front is the 8. So I end up with 8.76 times 10 to the, how many swoops are in between? But what do you know about your exponent? It's negative, so a negative 3. Try F on your own. Try F on your own. Oops. Greater than 1 or less than 1? Less than 1, which means I have a negative exponent. Currently, my decimal is between the 0 and the 1. Where do I need to put it for proper scientific notation? Here? Between the ones, correct? Okay. If it will actually let me cancel. So my front number is 1.14 times 10 to the negative first. Negative first. Okay, so we're like, yeah, we can write these numbers, so big deal, but what is the benefit of this? Scientific notation can help us determine which numbers are larger or smaller. Okay, so it says refer to the table at the right and order the countries in the amount of money visitors spent in the US from greatest, which would be your largest, to the least. Your exponent tells you how many times to move your decimal out. Well, the more decimals you move to the right, what do you know about the number? The larger it's getting. So if I look at these numbers, I don't want to have to write these out in standard form with a whole bunch of zeros. But I can tell you 10 to the 7th, I'm moving my decimal more than 10 to the 6th. Everyone agree with that?
Yep.
So 10 to the 7th numbers are going to be larger than 10 to the 6th. So I know Canada and the United Kingdom are bigger. Now, if they both have 10 to the 7th, then you have to look at the number out front. 1.03, 1.06. Which one's larger? 1.06. So the United Kingdom is actually the largest, then Canada. Then we had our two 10 to the 6th. Which one's bigger, 1.83 or 7.15? 7. So then Mexico and India. So you guys take a minute right now on G. Order the cities according to the number of visitors. Ooh, be careful here. Least to greatest. Write out the cities, least to greatest. Do not make those numbers standard form. Write your numbers, or country, cities, I should say, least to greatest. Don't write your numbers out. How do I know which one of those is the smallest? What am I looking at? I'm looking at the exponent. If I want the smallest number, that means I need to move my decimal the least amount. So 5 steps, 6 steps, 6 steps, 5 steps. Our 10 to the 5th are going to be smaller. Now, how do I tell the difference between those two? Now I look at my number out front, 7.21 versus 901. Which one's smaller? Okay, so the city with the least number of visitors? Boston. Okay, now I have a 10 to the 6th, a 10 to the 6th, and a 10 to the 5th. Which one comes next? The Metro DC area. Okay, now I have two 10 to the 6th. Same thing. Look out front. Which one's smaller? Las Vegas. And the city with the greatest? Los Angeles. The hardest part, I think, of this one is knowing, is it least to greatest or greatest to least, right? All right, flip the page to your guided practice. I want you to do 1 through 5 right now. That's exactly what we just learned. 2 with writing in standard form, 2 in scientific notation, and 1 least to greatest. And then we're going to go over them. And if you're unsure, go back. Look at the examples that we just did. Or A, B, C, D, E, F. All right, number 1, write each number in standard form. 9.931 times 10 to the 5th. You should have written 9, 9, 3, 1, 0, 0.
Yeah.
Perfect. 9, 9. Technically, where's your decimal point? At the end. If you have it there, great. If not, it's understood. That's totally fine. Number 2, 6.02 times 10 to the negative 4th. Decimal point, 0, 0, 0, 6, 0, 2. Make sure your decimal point is out front. Dang it. Number 3, 8.785 times 10 to the 9th power. Number 4, 5.24 times 10 to the negative what? 1. Very good. Least to greatest dollar amount. What year is the smallest? 3, then 4, then 2, and 1. This is what you're doing today. This is a summary of everything. So your homework isn't in your book, but if you need anything to be able to look at, these are examples out of all of them. There's not a ton of calculating, but you are going to need some swoops and things. Here's the deal, guys. You have a touch screen just like I do, right? Zoom in on Alex so you're not making mistakes because you miscounted. Yes, you have to turn work in. There's work paper in the back. 1-6 online.